Hello, and thank you again for joining us. My name is Yohannes Lamere, and I'm excited to jump into our second episode, which is all about sustainable fishing. Fishing is a vital part of many cultures and communities around the world. It is not only a source of food for people, but also a livelihood for many animals. It is important that we learn to manage the way we fish and the way we interact with the ocean in our coastal communities to ensure the future of our healthy, sustainable fisheries. This takes the collaborations of the communities to be successful. The Smithsonian is working on the science behind decision-making, using a range of tools, genetic analysis, catch data, habitat mapping, and socioeconomic data to help balance the needs of fisheries and the people who rely on them as a resource. Scientists can help guide the process, but ultimately, it is up to the local communities around the world to manage the successful sustainability. Let's take a closer look at the Smithsonian Marine Conservation Program in Myanmar.
My name is Iris Segura. I am a postdoctoral fellow in the Marine Conservation Program for the Smithsonian. The main focus of my research is population genetics on marine fisheries.
So one of the key parts of the Marine Conservation Program is how do we apply genetic tools to marine conservation problems. If we understand the species and how that population is spread across different parts of the seascape, and how people are using those types of resources, you can start designing management strategies that are based on science rather than a lack of information.
What we need to do is we need to understand the fishery. After better understanding the fishery, we can work out what is best solution to go to sustainable fishery.
My name is Du Yang Tun. I'm supervising the data collector because we have developed an application to collect the fish catch and small-scale fishery. This is our data collector. Now he's collecting the fish data. So now he's caught the fish and he scanned the ID of the fisherman and he collect the catch.
The challenge now is, can we understand fishing activity, understand the biology and ecology of some of these really important commercial species that communities depend on, and can we develop practices that enable that fishery to be sustainable, but at the same time protect the critical biodiversity that's so important for the planet.
And now, let's go to the Chesapeake Bay in Maryland to learn about the invasive catfish population and how the Smithsonian Institute is monitoring it.
Hey, Josh Bernstein here. I'm on the Patuxent River in eastern Maryland. I've come here to learn about this guy, the blue catfish.
Blue catfish are native to the Mississippi, Missouri, and Ohio River basins. They can grow to more than 5 feet in length and 100 pounds in weight. Blue catfish are an invasive species because the bay is not their native home. They have no natural predators, eat large amounts of native species of fish and invertebrates, reproduce rapidly, and have the potential for economic and environmental harm. I'm visiting with researchers from the Smithsonian Environmental Research Center to learn more. I'm meeting with Rob Aguilar. He has offered to show me how scientists solve the challenge of capturing and monitoring blue catfish populations in the waters of the bay. Because the catfish live in murky water of varying depths and they move around the bay, it's challenging to capture them. One technique Rob and his team employ is electrofishing.
Electrofishing started when?
It's been around for several decades. It's a really efficient, safe way to sample fish in low salinity environments where other methods just are impractical. Electrofishing allows you to get a good idea of the assemblage of fish or specific species of fish that you're looking for.
Electrofishing uses an electrical current, measured by frequency, to stun the fish so that they float to the top of the water.
With the catfish, we are using a lower frequency than you would if you wanted to assess the total fish community. The blue catfish are very responsive to this low frequency. So when we're fishing today, we should just see the blue catfish responding really well to the current that we apply to the water.
Yeah.
The electrical current is run through the water where the fish live, which can be dangerous if it's not done properly.
I'm wearing this so I don't get electrocuted. And you're gonna stay far away so you don't get electrocuted.
Electrocution can pose a serious risk, which is why I had to complete an electrofishing safety course in order to join Rob in this endeavor. I should also point out that electrofishing without a permit is illegal, so please do not try this at home. Having said that, electrofishing is pretty amazing science in action. On the boat, a generator connected to a special control box creates a current. One side is connected to the boat, which acts as a large single cathode. Off the bow, 2 anodes dangle into the water. The electrical current travels through the slightly saline river. Everything 100 feet around us will feel this charge, including people and other boats, so we must be very careful.
Rock and roll?
Indeed.
We're about to turn the generator on. It's gonna get noisy here. And more importantly, we're about to electrify this region, so you are gonna move away. About 100 feet. It's for your own safety. All right, we're live. We're fishing.
Within seconds, blue catfish start floating up to the surface.
There's one.
My job in the bow is to spot the fish, point them out to Rob, and net them.
All right, got one.
In the stern, Rob steers us towards the fish. What's fascinating to me is how effective electrofishing is. The frequency of the charge Rob sends into the water is truly species-specific. Only the blue catfish are floating to the surface. The other fish can swim away.
It's pretty wild. Second the current hits the water, boom, fish come up. It's kind of crazy.
Despite appearances, these fish are not dead. They're just stunned, which makes it easy for me to scoop them up and drop them into a tub of water on the boat.
This is like cheating when it comes to fishing.
By sending an electric current into the water, Rob and his team can capture and monitor a single species of fish and its population. This is important because the invasive catfish now makes up over 75% of the total fish biomass or weight in parts of the bay. This has consequences for the whole bay's food web, especially the fish, oysters, clams, and crabs they feed on. As for our original question, how do scientists use electricity to study fish populations? We can see that electrofishing offers a practical and efficient way to catch invasive species. Rob says we have enough fish, so it's time to take them for tagging, with an acoustic tag and Dart ID tag.
Today, we are joined by Smithsonian scientist, Mr. Stephen Canty. Welcome, Mr. Canty. Can you please tell us a bit more about what exactly makes for sustainable fishery and why they are important?
Absolutely. So sustainable fisheries are a balance between having enough fish in the sea that can sustain their own population, so they're reproducing and we keep getting more fish each year coming back into those populations. And so we have a nice healthy ecosystem with all the fish interacting with each other and doing ecosystem functions in the different habitats. We also need to make sure that the habitats, so could be coral reefs, seagrasses, or mangroves, are all healthy as well. And then it's this balance between how much fish can we take out so that the fish can keep reproducing and keep forming these really important partnerships with themselves and these ecosystems, but also making sure that local communities have enough income and also food to make sure that they are also healthy and have a good well-being as well. So it's really this balance between what does the ecology of the fish need, so its whole life cycle, and what do the people need, and making this balance between the two, making sure that we continue to have fish in the sea.
That's great. Now we have two questions that comes from students in Indonesia who are participating in the US Embassy English Access Program. Let's see what they have to ask you.
Hi, my name is Mumtaz from Senior High School Aysera, and I am the participant of US Embassy's English Access Micro Scholarship Program. So, I would like to know how you get know and understand a fishery, and what steps you take as a scientist. Thank you.
This is a great question, especially for small-scale fisheries, where sometimes it's really difficult to get hold of data. So, desktop studies are difficult. So a key piece of all of this is going into the communities, finding out how they're using the fishery, how they interact with the fishery. And some of this is what they're catching, how they're catching it, and where they're catching it. But it's also finding out how dependent they are on these fish stocks or fish populations for their income, what other opportunities are out there. So it's really finding this real delicate balance between all of what's going on within the community. And a key piece of this is integrating and interacting with the community is a key piece, because ultimately the resources belong to these communities, and it's these communities that will manage those resources, as they have the ultimate decision of how they go fishing and how they use those resources.
Hi, my name is Zulfi from SMA 69 Jakarta in Kepulauan Seribu. I'm an alumnus of US Embassy's English Access Microship Program. I would like to know, are you optimistic about the future of sustainable fishing? What can we do here at local level to help support sustainable fishing?
So I'm always trying to be optimistic, and I am, especially with small-scale fisheries. There's a big change more recently where communities aren't just being involved with management, but they're actually leading these initiatives. And through that, that's why I'm optimistic. They're leading it. They're in control of their resources, and groups such as Smithsonian and others are providing some science which is helping to guide the decisions that they're making. And then I would say at the local level, how do individuals make a difference, and how can you have some optimistic or conservation actions? And it's through what you buy. And I would recommend that you look out for some sustainable seafood guides, or talk with fishers or fishermen, fisher ladies, about what they're catching, what they think are good and sustainable catches or species, and then make those purchases based on that decision, knowing that you're consuming products that will keep are part of a sustainable fishery.
Well, thank you so much for joining us, Mr. Kanti. It sounds like collaboration is the key to the future of sustainable fishing, and I think you have helped us to be more aware of the relationship we all have to the ocean. Thank you so much. And now, we will take a journey to the cold northern waters of Alaska, where the interactions between people and salmon is a carefully balanced relationship.
Not everybody in Alaska is a fisherman, but all of us live on salmon land. The local farmers, they have little salmon streams that go through their property. If you look at a map of the Kenai Peninsula, it just looks like a cardiovascular system. Salmon are like the heartbeat.
The Salmon and People project is a combination of understanding basic science and ecology and communicating that information to decision makers, to people, to the public. And so the whole goal of this is to understand how the ecosystems work here, so that people have the option of making good decisions when they decide to do something on the landscape that won't degrade the resource. Everybody here loves salmon, and they want sustainable salmon. And we hope to give them the information that will enable them to do that.
Trying to find a hole that we got last period. There was something that came alive in me when I went out fishing that I hadn't really felt before. It was being connected to something that was bigger than myself and bigger than my 23-year-old girl problems, right? And it was the first time that I really felt that I could be part of a landscape and a people that I was proud of.
My father brought up 3 boys hunting and fishing and not throwing stuff away and not throwing garbage down, and so we slowly kind of developed into humans that took care of those resources. When you come home from work or you go through a divorce or the normal stresses in life, when I go down to the river takes all those stresses from me. I just don't think about other things, watch over your shoulders for bears, and enjoy that nature, because you live in a place where it's available to you, where you can walk to the river from here and walk to the beach from here. And everybody in life's probably looking for their idea of this. Here I feel it's our place to fight tooth and nail just to keep it healthy.
Everything about salmon is exciting to me. Right now I'm working with salmon vertebrae, and my process is gathering, processing it, and figuring out what I want to say with that material. For me, art has become so much more than object making. It's incredibly important that we feel connected, because we are connected. If we lose that sense, we lose our connection to our habitat.
The last few years have been really slow in Cook Inlet. And to a certain degree, that's normal for salmon. They have big boom and bust life cycles, and as fishermen, we are really used to just riding those out. But lately, it's been really, really bad fishing. Most of our fishing days this year have been really hot, and there's a theory that fish are swimming deeper, swimming in different patterns, and so we're not intercepting them. Temperature becomes a big problem too once they get up the river. Are the rivers cold enough to sustain those juvenile salmon? So is this part of our fish run's natural cycle, or is this related to a larger climate shift that we need to be worried about? We have more questions than answers about what's happening to our salmon here. It's been nerve-wracking to watch.
My name's Kui Walker. I'm the manager of the Ketchimek Bay National Estuarine Research Reserve, and Smithsonian is funding us and helping us connect with our communities, connect the science we're doing to the communities where those decisions and that science can be useful. What we've been doing over the past years is understanding how the baby salmon, which are living in the far reaches of the watersheds, how the landscape is supporting those streams, which is supporting those juvenile salmon, which most of us have never seen before. So today what we're going to do is just sort them, ID them, and collect stomach samples so we can see what they've been eating. What they've been eating, what we've learned, is directly related to the nutrients coming off the landscape. You know, that's the message we carry out. It's like, how do we conserve the landscape so that it's still supporting the food that the salmon eat and the salmon themselves. Let's find the plumpest fish we can. We all have to understand that what we do in the landscape around these streams is having an effect on those streams, an effect on those baby salmon. People all of a sudden go, oh, I don't want to hurt salmon. I want salmon to be there for, generations to come. But we have to make the right decisions as a group, or we won't have salmon.
So my goal in this is to see that salmon remain a sustainable resource here in Alaska. And one of the key things we've learned from this project is the linkage between the land, the wetlands, and the salmon. And if you degrade those resources, it's going to affect everything. When the water flows off of the land, it passes through the wetland before it gets to the stream, so that any kind of interaction between the water up there and the stream as it passes through the wetland will influence the ecology of the stream. When these plants die, they're going to fall over and hang over the bank of the creek, and then that becomes a source of organic matter for the creek itself. So we're going to measure that also. We have made a lot of mistakes around the world in how we've managed and changed ecosystems, and there have been huge consequences to that. We spend billions of dollars trying to fix things that we made a mess of. It would be nice to be able to take information, provide it to people so that they can still earn money, do things, but do it in a way that it's not altering the ecosystem and damaging it. And this remains one of the few places where we can do that.
Things are changing, and maybe permanently. Anything we can do to understand how those changes are affecting fish and how those changes are affecting the people that depend on fish will be great. More and more I've seen fishermen and scientists really working closely together and considering themselves part of the same team. That makes me think that we can weather bigger shifts as they come.
Salmon is the heart of the ecosystem here, and it's the heart of people too. So I'm just determined to do everything I can. Our partnership with the Smithsonian and the researchers are make sure that we can do whatever we can to keep things connected.
The more I realize how much resource I use, the more I realize that I should give something back. And if you don't do something up here as an individual, then eventually they'll go the way that the resources have gone other places. Then you just have a pretty place left, but nothing for fools like me to do.
It has been a pleasure spending this time with you. I hope that next time you visit the ocean or a stream or go fishing, you will think about what you have learned here today. If you would like to learn more, please go to the resource page on our website for additional information at earthoptimism.si.edu. And don't forget to be an Earth optimist. Thank you and see you next episode.